The title of this project is called Kilometer Zero. It was completed at the University of Virginia with the professor Brian Osborne. Kilometer Zero is based upon the thesis that the seasonal rhythms of a tree are a reaction to the environments in which it is situated. If the environment cannot be mended, the tree may be modified. Distorting a tree's hormonal equilibrium allows for the growth of trees in the harshest of environments, even otherworldly. Most importantly, within the sap, there are the pivotal growth hormones that control a tree's earthly seasonal rhythms. For instance, flowering, growth, flushes of leaves, so on and so forth. This digital data is taken by way of temperature sensors that are placed within the tree, and it monitors the temperatures of the sap. So one is placed above and one is placed below. And if the temperature is positive, sap is moving upwards. If the temperature is negative, the sap is moving downwards. And this is a highly calculated model simulation of the movement of those hormones within a tree trunk, within the most out of active cellular layer of a tree trunk throughout the day based on weather models, based on previous weather models. But what do these hormones do? So I keep saying them. There's 4 primary hormones. There's auxin, which controls the cell division and apical dominance. There's cytokinins, which aids in cell division and cell differentiation. Gibberellins in cell differentiation and growth induction. Abscisic acid, which inhibits all the other hormones. And so this is how it begins to look in this animation here. This illustration here is auxin, gibberellins, cytokinins, abscisic acid. And so adding to the whole plethora of plant surveillance, so plant monitoring, developed the integrated tree assistant, which here on the top left of the images, you see the first prototype, and here on the bottom right is the second prototype, which is currently in the works. So you can see it hangs from a tree, and within each tube, 2 highly sensitive temperature sensors are placed within the tree, and then it stores that data on an SD card. It's solar powered and is ready to go out to the field at any point. But it also monitors pressure, temperature, humidity, wind direction, and velocity.
Okay.
Directly starting the trunk. And so my hopes are the second part of this, of the integrated tree assistant, is to build the injection set, which is here. It's a common practice in tree management. And so the injection set would be networked to the ITA and would induce growth, stop growth, induce flowering based upon hormones that are injected directly into the trunk of the tree. Here is a test done on real Martian soil simulant. What we see here in this series on the left to the final image on the right is that water, and it's a fairly well-established gardening fact, is that by placing live soil into other soil, you enrich it, it grows, it disperses amongst other soils. And so that's what the root ball of the first tree on Mars would be. It would be that inoculant, is what I'm calling it. So we would inoculate Mars with this live soil and it would spread with the water.
Right.
Perfect. And so here we see a calculated representation of the viable surfaces for a tree to grow on, based upon slope, aspect, and elevation. The topography lines are uninhabitable, and the crosshatch is inhabitable surface. And so the third thing that the Kilometer Zero arrives with is this network, as a sensing swarm. We didn't get to exactly test it out here at UVA, but ideally we got very close. So each of these pins indicates where a sensor would be, monitoring particulate, humidity, temperature, pressure, ground moisture, so on and so forth. All the critical elements to life for a tree. And so all of these would be networked to the ITA. Here's the first prototype. We even got one in a tree here. Let's see on the bottom right. I am reworking this prototype. I think it needs to be simplified, but in any case, the framework is there to build. What I hope this project does is steers discourse about inhabiting Mars away from the bubble. Rather than climatizing the Martian climate, we must live within this pre-made structure. And so what I hope this project can induce is a discourse about how landscape processes and water processes can begin to inform our decisions about the first city on Mars, the first settlements, so on and so forth. So I think, so that we can walk in plein air, I think that would be the way to go. But also, I think what this project also does is creates a landscape process that we live within. And so what I imagine happening is that there's a feld zone here. There's a feld zone that we first inhabit. The timber that is felled is used for structures, damming RSLs, and circulation. And that all of these structures are temporal based upon the fact that they're made out of timber. And so as the